We've been doing a number of episodes on modernization. All of them have so far taken the assumption that you've had the time and resources to fully upgrade your system. Today, we're looking at it from a different angle. What happens when you don't have the luxury of either of those? Hello, and welcome to a brand new episode of Thought Exchange.
In OT, you cannot do it actually. You cannot push the patches directly. You cannot reboot the systems because if you do so, there are multiple things that comes to the challenge, even involving the human lives as well. This is the main challenge when we are bound to implement the cybersecurity because over the plants, over the sites, previously, what happens, there is no IT-OT convergence. There is no network segmentations. If any of the business requirement comes up that a particular or specific data or analytics required from the particular system, you just need to RTP from the business network to direct operational technology, OT network and ICS, compromise each and everything without any access control, without any encryption or without any VPN tunneling. In these layers, particularly the concern of yours is the data exchange from IT to OT, which is business critical, that is only reliable in level 4. In level 4 to level 3.5, we implement VPNs, we implement secure channels through which only one directional data is allowed. OEM told us this cannot be done on the application layer. So this is where the integrated engineering played its part. That we optimize the network layer, we optimize the virtualization layer. This whole activity was carried to achieve the redundancy, the failover scenarios. There were 4 links coming from 2 generators to our OEM. So those generators were provided by another OEM. So it was the point where INTECH played its crucial role integrating 2 OEM systems together. The outcome was that if any of the 4 links goes down, the other link should take off. According to the plan, he had to unplug the cable of one generator. So without redundancy, the data should go, and it really got out of the screen. After completely 5 seconds, there was complete silence in the whole electrical room. And after 5 seconds, when the data got back, without any interruption, physical interruption, there was a complete hands up on the table of the client, like this. We have done it.
We've been doing a number of episodes on modernization. All of them have so far taken the assumption that you've had the time and resources to fully upgrade your system. Today, we're looking at it from a different angle. What happens when you don't have the luxury of either of those? Hello, and welcome to a brand new episode of Thought Exchange. Today, we have with us Qanmber. Qanmber, welcome to the show.
Thank you, Ahmed, for having me. It's been quite a few years working with INTECH as an OT cybersecurity engineer. I've been doing the projects across Middle East for the multiple countries. So my main job nature is to provide the securities to our operation site and also keeping in view the criticality of the availability of the plant and sites.
So let's start our discussion with the root cause of the whole thing we're going to be discussing today, which is legacy systems. So I'm going to ask you, what do you understand about the challenges that legacy systems bring forward?
What I have learned in OT quite early is that you are very lucky if you have the modern system up ahead that you are going to secure. Normally, it's never that case. The legacy systems were designed years ago or sometimes the decades ago. On that time, the cybersecurity was never on the page, never on the paper, never on the minds that they have to secure the communication or they need to take care of some things that is authorization, they need to take care of something that is encryption, some secure channels, access control. There are multiple things. So I would tell you the real life scenario on this, especially if something is working to the operators from 15 to 20 years ago, you are not bound to touch that. You're not there to secure that. You have no authority to do something, so that may operation get challenged with.
Yeah, I think the main reason why is because back when these legacy systems were designed, they were not designed to be interfaced with the real world outside of the plant environment.
Yes. The main thing of those legacy systems was to provide the availability so that they may run a long race. So there must be no challenges that come up in the future. Their operations are working fine because that's where OT and IT differs. And IT, you can simply, if a jump server is not working, it may be, we are in the IT field right now. We are in the office environment. That is completely IT to you. So
turn it off and on again.
Yeah, exactly.
You
it's
can't do
very
that
easy
with an
for
OT
them. If
system.
something is not working, if this mic is not working, you can turn it off and on. Maybe it gets fine. And usually it gets fine with that. In OT, you cannot do it actually. You cannot push the patches directly. You cannot reboot the systems because if you do so, there are multiple things that comes to the challenge, even involving the human lives as well.
But that doesn't change the fact that modern business requirements now do rely on a significant level of data coming from the OT systems. business managers do need to see what's happening at the plant level. That information does feed a lot of the business decisions. So, what do you see happening at the plant level to meet these requirements, which may not be very safe or secure?
This is the main challenge when we are bound to implement the cybersecurity because over the plants, over the sites, previously, what happens? There is no IT/OT convergence. There is no network segmentations. If any of the business requirement comes up that a particular or specific data or analytics required from the particular system, you just need to RDP from the business network to direct operational technology, OT network, and ICS, compromising each and everything without any access control, without any encryption, or without any VPN tunneling. You
You're
just
saying
achieve.
they would remote desktop directly from a business network to maybe a server at the plant?
Yes, without any jump servers. So, and even without any, you can say, VPN tunnels. There are particular tunnels.
Yeah, so
So this is where actually a lot of your OT incident happens. Let me quote one of the scenario that I tackled just in the previous of my project is that we were there to secure the workstations. We need to implement antiviruses and block the physical ports of the systems. So when we investigated, we got to know one of the operator, when his phone dies, he used to charge his phone from the workstation,
directly from the workstation.
directly from the workstation, and that's it. For his, it's quite of an ease. He doesn't need a charger for that. But if you count or recall the Stuxnet,
Yeah, that's how Stuxnet happened.
Yeah,
it was a
the same
USB.
So that's why we, as a cybersecurity engineers, we go there and implement controls to secure the physical access and as well as the network access by segmentation and multiple scenarios.
As a cybersecurity expert, uh, how would you address all of these issues where people are, getting direct access, remote desktoping into a server environment, or taking data from your plant systems, taking into account that you are dealing with legacy systems where safety patching or and even touching the system maybe in some cases may be very challenging. Uh, how do you handle cybersecurity there?
Starting from the IT/OT convergence, for this we follow a standard called IC 62443. There are multiple clauses of that. According to that standard, we need to segment our OT network into layers, starting from layer 4 to layer 3.5 to level 3 and level 2 and level 1. In these layers, particularly the concern of yours is the data exchange from IT to OT, which is business critical. That is only reliable in level 4. In level 4 to level 3.5, we implement VPNs, we implement secure channels through which only one directional data is allowed. Like only one directional data will go to the business layer, not the multi-directional. What in this particular scenes, in this particular scenarios, what we do, we implement data diodes, which is only unidirectional, and using those we can easily transfer the data from OT to IT without having a direct jump from IT to OT. There are jump servers that we implement with secure controls that you can have access to multiple systems.
So from level 3 to 3.5, you would have your jump servers.
From level 3 to 3.5 and maybe from 3.5 to 4, depends upon the requirement of the clients. The next thing that you have asked, the legacy system and their patches, this is only the other difference that comes in the IT. In IT, you are very aggressive in throwing the patches. If there is something getting obsolete, you just need to throw the patch and that's it. While in OT, there are a lot of vendor restrictions. There are a lot of OEM recommendations that you cannot do this and you cannot do that. So for that, in OT, it's not just directly pushing up the patches. You need to calculate the risk for that. You need to know what Windows is running on your system, what security or cumulative patch it has before, and what is the next one, and what is the qualified patch list with that. Uh, Usually, this QPL qualified patch list provided by the OEMs, such as Honeywell and Rockwell. There are multiple OEMs which provide you that. So it is a complete risk calculation before we do anything in operational technology.
So you mentioned that the IEC 62443 guides you to separate the plant into different layers, and uh, we've talked about layers 3, 3.5, and 4. That's where people assume most of the plant to industrial level communication happens. But what happens below layer 3, especially when it comes to cybersecurity for the systems that are below that layer?
Actually, the real OT cybersecurity is not just adding up the patches. It's not just adding up the antiviruses, either the backup systems. It actually understanding the flow of operations. It actually goes hand in hand with cybersecurity, that if you're going to implement something, you should not be compromising the operations of the plant. So this is actually where the real challenge to cybersecurity comes up, because in below level 3, there are very critical things such as ESD, DCS, FNG. Multiple controllers are playing their critical part in keeping alive the operations of the plant. So you cannot just always segment the network. You just need to analyze the situation. What will be the impact? What segmentation can bring up to you, and especially the communication between this L2 and L3 is right the moment where the cybersecurity take parts in, and how the things are going to the secure channel. The communication in L2 particularly is very critical, because the real-time data exchange is very important to the operators, because usually operator workstations and engineering workstations are the part of level 2 and level 3.
There's typically no real time data communication from level 2 to level 4. But what if you do need some data from there? Is there any critical data at level 2 that you would want to see in real time at level 4? And if so, how would you go about it?
So yes, actually the real-time data is never required from level 2 to level 4. It's just the business analytics that is later on shared to the level 4, definitely through the layers, and then the business cell can actually see the analytics of the system. The real-time data is only required in level 2, maybe in level 3, but level 2 is quite critical in the terms of real-time data. For that, there are particular protocols such as OPC DA. If I quote OPC DA, now the latest technology is about OPC UA, which is quite secure, more of the certificate exchange kind of thing. Encryption is there. So we implement those kind of controls in level 2 for the real-time data, such as the data from the generators. You need to know the temperature, the rotations per minute, like what is the output of the electricity the generators are producing. So such kind of data is quite critical for the operators to keep an eye on. So that is the thing they monitor 24/7 and highlight the flag if anything goes wrong.
So OPC UA, as far as I know, is a much newer protocol. It came out in the maybe last 10, 15 years. Is it compatible with legacy systems?
OPC UA is, yes, a new protocol in the industry, and the old legacy systems requires a minor upgradation for that to get the compatibility with the latest protocol, since it is require more CPU utilization and more technicality wise security and controls to be implemented. So yeah, there are few
So
challenges.
if you need to install that at a legacy system, you will need to upgrade something with the legacy system.
Yes, this is the point where it gets very interesting, because recently we had conflict with OPC UA, especially when it comes to its integration. The application that we had was quite comfortable with that, but the only challenge was, since it is the latest technology, the redundancy of OPC UA was never on the chart.
So
So
this was during a project.
yeah, this was during a project and highlighted quite late for that. But this is where the OEM was not able to provide us the solution for redundancy, because it is not just straightforward that you implement OPC UA and that's it. You're okay with that. But the redundancy is very critical in OT, especially when you consider the availability of the system on the operation side. This is where the level 2 is where you cannot compromise on the availability of the system.
So how did you handle that situation?
That is something when OEM told us this cannot be done on the application layer. So this is where the integrated engineering played its part. That we optimize the network layer, we optimize the virtualization layer, we created
But
virtual servers for that.
was the OEM saying it's not possible, or were they saying you need to upgrade your hardware and
Usually, when you
firmware?
go to such conflicts with OEM, there is a single line that OEM used to prefer, and that is not possible. Full stop.
Wow.
So, from the integration point of view, from the services, we should think out of the box to achieve the goal.
So what was your solution out of the box?
So, out of the box was we got to know that application level cannot be changed. To do that, to achieve that kind of redundancy, you need to go into another upgrade. That is more costly, that is more definitely requiring time, because the operations were meant to be alive in 3 days, but we had only 1 day left to conclude this activity. So we sat, we started to brainstorm, we started to think out of the box, and then we utilize our resources which are available over the site, especially the part of the upgradation project. in which we had to create virtual servers and achieve a redundancy for downtime of minimum 5 seconds, which is a lot, but still we cope up the situation with virtual servers on the network layer and provided the redundancy on the application level.
What was the outcome of that activity? What impact did it have on the plant?
So the major impact it was carrying, this whole activity was carrying to achieve the redundancy, the failover scenarios. There were 4 links coming from 2 generators to our OEM. So those generators were provided by another OEM. So it was the point where INTECH played its crucial role integrating 2 OEM systems together. The outcome was that if any of the 4 links goes down, the other link should take up. And there was a pair of those 4 links into pair of 2. So what INTECH did, INTECH configured, we configured something related to virtual servers, mapping those 2 links on one server and telling the client side that there is only one link that you have to put up. The data will go for minimum 5 seconds and it will take up the another.
So we provided redundancy at our level to make sure that the
Yes.
system would stay safe
Yes.
without affecting any of the
Yes.
legacy.
And I still remember that time when we were testing this, because the implementation goes by, the real challenge comes up when client comes up and says like, okay, you have done this, I will challenge it. So it was like the first link, when the communication was all fine, it was all healthy. According to the plan, he had to unplug the cable of one generator. So without redundancy, the data should go, and it really got out of the screen. After completely 5 seconds, there were complete silence in the whole electrical room. And after 5 seconds, when the data got back without any interruption, physical interruption, there was a complete hands up on the table of the client, like this. We have done it.
Nice.
So this was quite of an experience to do this.
So this story is a really good example of how you can still achieve the data sufficiency that comes with requiring some level of modernization, which is the main goal of modernization, without actually compromising or going for very expensive upgrades on legacy systems. So thank you. That I think we've all learned a very interesting story from Qanmber today. Thank you for joining us, Qanmber.
Thank you so much, Ahmed, for having me. It was a great time.
And thank you, all of you who were here until the end of this story. Please be sure to check out our other episodes on the links to the side, and we'll see you on the next one. Thank you.